Alright, so now we're on the 3.5, on the subtopic number 3.5, the 3 sets Venn diagram. So what does it look like? Just like Dini Bly, the 3 set Venn diagram is just a Venn diagram which has 3 sets. So how is it represented? Just like it is seen here. So here in the middle, you have the part of A intersection B intersection C. Here, right in the middle. Then here, you have Tx. And now A intersection C. Intersection C only. Here you have B intersection C only. Here you have A intersection B only. Here you have only B. Here you have only A and only C. So here I cannot write it, but it is A intersection B intersection C. So here, this part here in the middle represents an element which is common to all of the sets. So this part here represents an element which is common only to A and B, to A and C, for instance. This part is represent an element which is common only to B and C, and here only to A and E. So let's solve an example and look at how it's going to look like. So I have example 1. You have and zeta is equal to 1, 2, 3, 4, 5, 6, 7 from 1 to 12. Alright, we have our set A as here has 2, 3, 5, 7, 11. 2, 3, 5, 7, 11. Write B here to save space. 2, 3, 4, 6, 7. 2, 3, 4, 6, 7. Set 3, 6, 9 sets. 3, 6, 9. So B is 2, 3, 4, 6, 7. 2, 3, 4, 6, 7. Okay. So the question says is to represent this the Venn diagram like that. So let's try representing this thing in that Venn diagram. So what are the steps you want to do if you want to represent it in Venn diagram? The first thing is you will look for this. As for the two sets Venn diagram, we're looking firstly for the intersection, for the highest intersection. In this case, the highest intersection is the third one. A intersection B intersection C. You see there are 2 intersections. So you always look for the highest intersection. In this case, you first look for A intersection B intersection C. When you find this intersection, you find this one, this one, this one, before finding bigger ones. So you start by finding the intersection. It's going to make your work way easier. So what is A intersection B intersection C? Means everything that is in A, but it's also common to B, and that is also common to C. So let's check for the numbers. We have 2 in A, 2 in B. There's no 2 in C, so a variety. 3 is in A, 3 is in B. There is 3 in C too. So you write that 3 because it is common to everything, so all of the members of a set. So we have 5 in A. There's no 5 in B, so you don't write it. 7 in A. There's no 7 in B, you don't write it. 11 in A. There's no 11 in B. So since you have gone through A, we don't need to stand back with B. Because if A is finished, then there is no new element that will match A. Because we have already gone through all of the elements of A. So A intersection B intersection P. We're wanting the three. So what next? What I'll do this. We check these intersections. Let's start in A intersection C only. So what is A intersection C only? We mean elements which are common only to A and C, which are not common to B. If I say A intersection C without the only, then this 3 will also be inside. But we don't want this 3 to be inside because it is A intersection C, but also intersection D. So we want it to be A and C, but not found in B, so that we can put here and not in the middle. So what is common to A and C and not to B? So let's check. 2 is in N, we put 2 in C, so you don't write it. 3 is in A, 3 is in C. Is 3 in B? Yes. So you don't write 3 because it is also in B. It has to not be in B. So let's go to the next. 5 is in A, is 5 here? No. 7 is in A, is 7 here? No. 11 is in A, is 11 here? No. So we see that there is no value, it's an empty set for A intersection C only. Let's do now A intersection B. So for A intersection B, what is it going to be? We want terms that are common to A and B only. So not common to A, B, and C. So for A intersection B, you take terms common to A and B only. You have 2. 2 is common. Is it the C? No. So you write, we're going to have it 2. Because it is common to A and B and not common to C. So you write it. Here you have 3. It is also common to B. But it's also common to C, so you don't write it. Here there is 5. 5 is common to B, no. Here there is 7. 7 common to B, no. Here there is 11. 7 common to B, no. So we leave it like that. That is it for A intersection B. For B intersection C, only. For all of these things, you can also use the formula method. Normally, if you are looking for, okay, let's try and find the intersection B using the formula method, because all we have done here is using our logical thinking and we had it. Let's use the formula and see if we are going to have the same thing. So, for A intersection B, okay, here is for 2 steps as no. Well, okay, for A intersection B, what do we know? What do we know here intersection B as? It is okay, here there is no, alright. So here you will normally just do logical thinking because they are not two. The values for the formula for the 2 sets will not work the same for the 3 sets. So you use a logical thinking and find A intersection C. So you find terms that are common to A and C, which are different, which are not found in D for A intersection C. Same for A intersection B. You find terms that are common to A and B, which are not found in C. So we do same for B intersection C only. So we check terms which are common to B and C, which are not found in A. So what are the terms? You have 3 and 3, but 3 is found in A, so we don't put it. We also have, okay, it's B that you can see. We also have 6. 6 is in C, 6 is in B. Is 6 in A? No, so we can write the 6. We have 9. Is 9 in B? No. We have 12. Is 12 in B? Yes. Is it in C? No. So we can write it. So this is B intersection C only. 6 and 12. So now I left with what? I've done this. So, okay, we're done all the intersections. So now I start doing A only, B only, C only. So what is beyond it? Misters which are common to A, which are not common to B and C. So let's start checking. 2 is 2 in the yes, you don't really put it again. Let me open my curly bracket. 3 is 3 in the yes, no, keep it. 5 is 5 in the no, is 5 in C, no. So 5 is only A, keep it like that. 7 is 7 in the no, is 7 in C, no. So 7 is also only A. 11 is 11 in B, no. 11 is C, no. So 11 is also only the gate. So now we're looking for B only. So for B only, we say we look for values of B, which are nowhere else. And I said nowhere else, I mean not in A and not in C. Because you don't compare it and C with zeta. So what is B only? Check B and check if it has elements which are not common to any other set. So 2 is in A, so you don't put the 2. 3 is in A and B, so you don't put this name 3. 4 is going A, no, is going C, no. So 4 is only in B, so I put my 4 there, only in B. 6 is 6 in 10, no, is 6 in C, yes. So I don't put a 6 because 6 is in C. So solving A, low is solving C, yes. So I don't put it. So my only value for B only will be 4. What's the C only? So for C only, we'll do same. We look at C and we try finding values in this C which are not common to A and B. So let's start with 3. 3 is common to A and B, so we don't put it. 6 is not in A, the 6 is in B, so we don't put it. 9 is not in A, 9 is also not in B, so we can put our 9 here. Comma 12 is not in A, the 12 is in B, so we keep it. We don't put it. So now we have all of our values. We can now see the Venn diagram. Let me just move. So we can now see the Venn diagram. But before, we should also find the year. Numbers that are here in none of the 3. So to find the numbers that are not in none of the 3, do epsilon minus A union B union C. Oh, you pay. If you use the logical thinking, you just find numbers which are here, which are in none of the 3. So let's start 1. Is 1 in any of these? No, there is no 1 in any of it. So you write the 1. Let's go. Let's continue with 2. Is 2 in any of these here? There's 2 here. There's 2 here. You don't write 2. Is 3 in any year? There's 3 everywhere. Is 4 in any years? There's 4 here. Is 5 in any years? There's 5 here. Is 6 in any years? Is 7 in any years? There's 7. Is 8 in any? No. It is not. It's neither in A nor B nor C. It is not in any sets. So you can write it. Is 9 in any sets? Yes, 9 is here, so you don't write it. 10 is it in any sets? No. 10 also is neither in A, B, nor C, so I can write it. Is 11 in any? Yes, this is 11. Is 12 in any? Yes, this is 12. So these are all of the elements which are neither in A nor in B nor in C. So now we have everything to be able to put it in our Venn diagram. So now Venn diagram we are going to have A intersection B intersection 3 intersection C as 3. Sorry, I'm not 3 here. The what X A and C only is an M set. This is A and C. The point of intersection is here. Since it is an empty set, I leave it empty. I don't write 0, I leave it empty. 0 means it has a set with the number 0 inside. So A intersection B only is true. So if I said A intersection B, A intersection B, the B is in here. The point of intersection will be here. So this is A meeting B at this point only. So the intersection B all is true. I can put my T. B intersection C only is 6 and 12. So this is B and C. The point of intersection is here. So I have 6 and I have 12. 6 and 12. Now A only is 5, 7, and 11. So A only I'll write here 5, 7, 11. That is for A only. B only I have 4. 4 is B only. C only I have 9. Five, 7, 11 is A only. 5, 7, 11. Now for Niger, this antizeta minus all of it will give you what is outside. So what is outside is 1, 8, and 10. 1, 8, 10. If I arrange your values any way you want, it's similar to the parent. So let's take another example. So that is what it looks like. The other example says it's actually a word problem. It says in a survey of 100 students, so we have 100 students. This survey about you students. We have 45 who study science. 45 study science. We have 40 who study English. Let's call science as 40 study English. Let's call my English as E. We have 20 who study math and science. Okay, 50 study math. 50 study math. Let's call math M. Now we have 20 who study math and science. 20 study math and science. We have 50 who study math and English. 50 study maths and English. 80 study science and English. 80 study science and English. 8 study all 3 subjects. So this is the data. Find A, how many study only math? B, how many study exactly 2 subjects? C, how many study at least 1 subject? D, how many study none of the 3? So you should know the steps in solving these type of problems. The first step is to find A intersection B intersection C. That's the first step. So you should find the three-step intersection, the three sets intersection. The next step, we find all of the two-step intersections. Then the next step, find the only ones, the onlys. And then you find the neither. And there is this. And then after you verify I told us, make sure that it is the same like your sample's case. Yeah. Zeta. So let's start solving. So this is our beta. Like this. So what do we do first? We look for we first wipe the letter that is here. So firstly we look for the one in the middle, A intersection B intersection D intersection C. Fortunately here the weight given is also it is 10. So I can write A intersection B intersection C all 10. I come up with my 10 here confidently. Because it says the 10 students do all of the subjects. The next one now, we find these onions. So you want to find A intersection. Let's start with A intersection B on. So A intersection B only is equal to what? It is equal to A intersection B minus, this is the formula. A intersection B intersection C. Remember, if you want to find L of A, if you want to find A only, it will be A minus A intersection B. Now, if you people A intersection B only, it will be A intersection B minus A intersection B intersection C. You see, the C just develop an intersection. A equals A minus A intersection B. A equals A minus A intersection B. Here it is. A intersection B equals A intersection B minus A intersection B intersection C. You see that if you let this to be M, you have N is equal to N minus N intersection C. N is equal to M minus M intersection C. The same like A is equal to A minus A intersection C. That is A only, M only. You see, this is the same form as here. So use the same formula now, find this. So what is this going to be? We have A intersection B only is equal to A intersection B minus A intersection B intersection C. So what is A intersection B? Oh. In this case, we have science, English, and maths. So we have S. In this case, it will not be A intersection B intersection C. The science, English, and maths. So that's the post part. Science intersection English intersection maths is equal to 10. Now I want to know science intersection English only. That will be equal to science intersection English minus science intersection English intersection maths. What is that going to be? What is science intersection English? Science intersection English, it is 18. 18 minus science intersection English intersection maths is 10. That's going to give me 8. That's S intersection E only. And I have S intersection E on my bits here. So next, I find S intersection N. S intersection N only. So what is S intersection M only? You mean S intersection M minus S intersection N intersection E. S intersection N intersection E is the same like S intersection E intersection M. So if you want S intersection E intersection M, okay, S intersection E intersection M is equal to S intersection M intersection E is equal to maybe M intersection S intersection E is equal to E intersection M intersection S. Any combination. This means that any position where you put the S or the E or the N, it is always going to be equal. It's always going to be the same. As far as the three sets are included, their intersection is always going to be the same. So it's just like multiplication is commutative. So if I put S intersection N intersection E, don't be confused. It is the same like S intersection E intersection M. So what is S intersection M? So as an M, it is 20. 20 minus 10 equal 10. So now, I am now looking for, I've already had S intersection E, S intersection M, E intersection M. What is that going to be? Oh yes, only E intersection N minus E intersection M intersection S. So what is that going to be? E intersection M is what? I look for what is E and N. E and N, it is 15. 15 minus 10 equal 5. So here I have S intersection E. I've written there already. Is S intersection M 10? S intersection M is 10. Now S intersection M is 10. We have E intersection N is 5. E intersection M is 5. So now that we have all the intersections, we can find the onlys. So now what is S only? S only will hit the actual S minus all of the intersections. So if you put the actual people that are doing science and you remove all of the people that are doing science and other subjects, we're going to have the people that are doing only science because they have removed the people that do science and a part of the other subjects. So you will do, and this equals to S minus all of the other intersections, minus this intersection, minus also any other intersection that contains S. This one and this one. So I want to do this minus this minus this minus this. So minus in. I'm just writing them. It is, so here S is 45. Alright, it's 45 minus all of the intersections. So you write all this in S, then you remove all of these intersections. Minus 10 minus 10 minus 10. Then you are going to have S only. So what is that equal to? 17. You do same for E only. E only, you write? Okay, for S only, for hack 17, I write it there. Same for E only. For E only, I write my E. He was given to me as code C. Minus all of these intersections inside D. We have 8, 10 on the fifth, and 5. Minus 8, minus 10, minus 5. What is that going to be? 17 also. Reducing for M. M only is equal to the actual M, which is 50, minus all of the other intersections inside M, we have 10, 10, and 5. Minus 10, minus 10, minus 5. We equal to 25, I think. Yeah. So when you have done all of this, here is 25. When you have done all of this, now you will look for the values which are here. In neither of them. So for neither, all need be equal to, will be equal to the actual sample space minus everything that is here, minus S union E union M. That will be what is here. So in neither you have the antecedent minus S union E union M. So when you do this, what you're going to your calculator, you just do. Okay, you're not using a calculator here from 2 where you just add this and this and this and this and this and this and this. You add all the terms in the sets, all the sets, you add them one time. So it to 17 plus 8 plus 17 plus 10 plus 5 plus 10 plus 25. When you have your answer, you're going to take our sample space 100 minus our answer. When you add all of it, you're going to have 98, I think. 92. Alright, we're going to have 92. When you add all of these things, you're going to have 92. When you have your 92, you take 100 because 100 is the total number of students. So the total number of students that was in this key was 100. When you write E, you make sure you write the total number of students beside it. Now, you take those 100 students minus all of the students that are doing courses, subjects. That 92 students that are doing courses. You will left 8. So outside there you have 8. And that is all. That is all. You have done everything. You have represented it on a Venn diagram. So whatever question they ask you now, you solve easily. You can answer it easily. The A part says, how many study only maths? How many study maths only? Or your answer to it, 25. The B part says, how many study exactly 2 subjects? How many study exactly 2 subjects? How will you do it? You look for people that have exactly 2 subjects, like yeah, and yeah. So yeah, the 2 subjects are science and maths. Here the 2 subjects are English and maths. Here the 2 subjects are science and English. So you do 10 plus 5 plus 8, you're going to have 23. That will be your answer. Then the next part says, how many study at least 1 subject? How many students study at least 1 subject? Means you can take students that study just 1 subject, like here. You also consider students that study 2 subjects, like here. And you also consider students that study all of the 3, like here. So you add up everything one by one as majority. Your answer is going to give you 92. So if they ask you for how many at least study 1 subject, it means you are going to add up every number here. It is just S union E union 10, but they're asking you for. That is the number of students study at least 1 subject. And then the last question here says, how many study none of the 3? How many students study none of the 3? It is neither. Neither is actually this 100 minus this 100 because 100 is your sample space. They told you there were 100 students. So 100 minus all of the people that study at this 1 subject is equal to all of the people that don't study any subject. So in that case, 100 minus 92 is 8. I have answered the question. So that is all for the first problem. We can now go to the second problem. So what for them to let output. So we have in a group of 120 people. So when they say in the group of 120 people, it means this is your sample space. It is a universal set. Ci zeta. So in this case now it is 120. So let's start back on light of this. So our sample space is 120 people. Now 70 like apple. 70 like apple. Yeah. 50 like oranges. Okay, 70 like apples, 50 like oranges. We're gonna call this A, this O. We have 60 like bananas. 50 banana, we want to call this B. We have 60 like, okay, 60 like bananas. Here 60. So 20 like apple and oranges. 20 likes apple and oranges. What else? 25 like apple and bananas. 25 like apple and bananas. What else? 15 like oranges and bananas. 15 like oranges and bananas. What else? 30 like pot. These two things just means light is repeated down. This is light, this is light, these two things just mean light. Light. So you can replace the symbols by light. And so you have to form a Venn diagram with this information. So what do you do first? So the first thing I will do is we look for A intersection B intersection C. In this case, it is A or B. So I'll put A, B here, I'll go here. Because A and B like B together. So what is A intersection B intersection C? It is given to us as 10. 10 people like out of it. So I write here 10. Now, what is A intersection B? Only because when is intersection, what I have to look for first is these or intersections here before looking for the pondis. So A intersection B only is equal to A intersection B minus A intersection B intersection C. So it is equal to A intersection B. What is A intersection B? 25. A and B is 25. So 25 minus A intersection B intersection C is 10. That is equal to 15. So now what is A intersection O only? A intersection O only is A intersection O minus this 10, which is A intersection O intersection B. So what is the intersection O? Where do I see the O? Apple and oranges, they are all together. So we had it is 20 minus this our 10, which is equal to 10. Next we have A. Okay, we are going to have O intersection B. What is O intersection B? So people see this and will ask you, why is it not B intersection O? Or why is it not O intersection B? You have to know that A intersection B is the same like B intersection A. And that A intersection O is the same like O intersection A. And that O intersection B is the same like K intersection O. So what is O intersection B? I look for where I see 1, B, I see, I'm seeing 15. 15 minus 10, but it's going to be 5. I can represent this immediately if I want. A intersection B is 5. It's 10, it's 15. A intersection B is 15. A intersection O is 10. A intersection O, I have 10 here. O intersection B is 5. O intersection B, the corner intersection is here. My 5. Now I'm looking for the onlys. A only will be equal to the actual A, which is 7C, minus all of these intersections here. Because I'm looking for what? I'm looking for apples only. I'm looking for people that like apple only. They don't like any other thing. So what is it going to be? It's going to be the total number of people that like apple minus the people that like apple and other things. Because the medicinal intersection means these people like apples and other things. So I find the total number of people that like apples, and for mix, I remove everybody that like apples and any other thing. So from here, I can see that there are 15 people that like apple and bananas. There are 10 people that like apple, bananas, and oranges. And then there are 10 other people that like apple and oranges. I have to remove all of them. So I'll do 70 minus 50 for this, minus 10 for this, minus other 10 for that. That's going to give me what? 50 minus 35, that's 45. That's 35. Okay. Okay, that's 50 minus 35. That's for A on there and put my 35 here. You see, if you add this plus this plus this plus, I'm going to come back to the 7th that I copy. So we are at bananas only. Bananas only is the number of bananas originally, which were 60, minus, you remove these things. 15 minus 10 minus 5, that is equal to bananas only 30. Now I'm saying for oranges only. Oranges only is equal to the total number of oranges, which is 50, minus the number of people that like oranges and other things. So when you subtract the total number of people that like oranges from the number of people that like oranges and other things, we are going to have the total number of people that like only oranges. So, which is, here rubbers as 50. 50 minus all the people that like other things, you have 10 minus 10 minus 5. How is that going to do? 35 minus 50 minus 25. So 50 minus 25 is 25. So the next one, what do we look for? I can write here my bin 5. I'll look for neither. To find neither, I'll need to know what is my B30. I'm looking for neither. To find neither, I need to know everybody that likes at least one fruit, so that I can subtract it from my zeta and have neither. So at this one is equal to what? I'll do this plus this plus this plus this plus this plus this plus this. So when you have folia, here you do this plus this plus this plus this plus this plus this. You are going to add the body. So it is 35 plus 15 plus 30 plus 10 plus 10 plus 5 plus 55. So 35 plus 15 plus 10 plus 10 plus 10 plus 5 plus 25. This is it. 35 plus 15 plus 30 plus 10 plus 10 plus 5 plus 25. And I am going to have 100 times. I'm going to have 130, which is actually more than our antecedent, which is 120. So we'll have, assuming this is 100. Assuming this is 100, because normally it's not supposed to be more than our antecedent. So let's assume it's 100, because normally it's not supposed to be more than our antecedent. So let's assume that, okay, no, we don't assume, 110. So it was 140 at the beginning. Just it's. Okay, 135. Okay, so this one is 135. So now no the number of people that are here. How do I do? I do my epsilon minus. I'm going to know the neither. I'm going to do my antecedent minus 130. Antecedent is 135. That's going to give me 5. And with that, I'm done. Now I can start answering all of my questions. How did the question say? The A part said, how many like apples only? How many like apples only? Apples only is 35. The B part says, how many like exactly 2 fruits? So this is 2 fruits, 2 fruits, 2 fruits. So 10 plus 15 plus 5. What is 10 plus 15? It is 25 plus 5 is 30. So you say the answer is 30. Now, the C part says, how many like none of these fruits? 5. Because 5 is outside. We take the sum of the other like the fruits minus our sample space for our universal set. The number of elements being universal. There are 135 people. So that's why I'm going to 105 for my house. 130, I'm going to get 5 people, or not like any of them. Alright. So now you are going to take example, maybe for some time. So what we did, if you found this middle first, then A intersection B, A intersection O, O intersection B, this and this. They will find A, B, and C only. And then we'll find the least one. So we add up everything that is inside. And then we find a neither to know which people don't like any fruits. So we subtract our sample space from that sum that we added. Or however you try. And we product all of them, we plug all of the answers there and answer the questions. So I'm going to do a 10th example on our word problems. So example 3 says in the survey that 80 people some people interviewed 80 people, that is our sample space. 40 play football. 40 play football, let's call it F. Yeah. There's 5 play basketball. Let's call it D. 30 play volleyball. Let's call it V. 15 play football and basketball. 15, 12 play football and volleyball. And 10 field basketball and volleyball. And fathers play all of them. Now here, they are looking for so the A part says how many play only football. The B part says how many play exactly the one sport. The C part says how many play at least one sport, and the D part says how many play no sports. So to do it, we want to draw a Venn diagram. So in this case, we represent zeta as yeti, football, basketball, volleyball, B. Okay. Football, basketball, probably. So, there are more looking at the inside and outside. You see. So, as usual, we first find our A intersection B intersection C. So, already B, it says 5 players. So, we have F intersection B intersection D is equal to 5. 5 players play all of them. What next? We are told that we want to find out this. So, football intersection and the basketball only will be equal to football intersection basketball minus this 5. Minus that 5. What is that going to be? Football minus basketball. Football intersection basketball is given to us football and basketball. So the intersection is 15. You have 15 minus 5, which is equal to 10. Now we are looking for football intersection volleyball handy. What is it equal to? Football intersection volleyball minus football intersection volleyball intersection basket, which is 5. And that is equal to football intersection volleyball. What is going to be? Football and volleyball is 12. 12 minus 5. That is equal to 7. That's step and B only. Now, I'm looking for football. I'm looking for volleyball and basketball only. That is supposed to be volley. That's when we out to volleyball into basketball minus a 5. We're always subtracting the 5 because the 5 is the general intersection. Because the 5 is already found inside football intersection basketball. So when we say football and basketball, this 5 that is everywhere is already inside. So we want football and basketball only without the 5 that is everywhere already by default. So that's why we do this. So we have D in the string B, which is volleyball and football and basketball. 10 minus 5, 5. So you can only write F intersection B only is 10. F intersection B only, we have 10. F intersection V, we have 7. F intersection V, 7. And V intersection B, 5. V that will be the breadth of 5. So now we're going to find f onlys. So to find f only, set only is factually f minus all of these intersections. So it is f, the x to 40 minus all of the intersections, 10 minus 5 minus 7. Okay, wherever you're looking for f only, you do your f dots give it to you, 40 in this case, minus all of the intersections that are inside f. So you now go and take this part because this part is not at any intersection touching f. It's not inside f. So you take all of the intersections that are inside f. You have 10, 5, and 7. And that's going to give you 10, 5, and 7, 18. Is equal to 18. So I can write here 18. I'll do same for b only. B only will be equal to our actual b, which is 35, minus all of the intersections in b. The intersections in b are 10, 5, and 5. So it's b only is 35 minus 10 minus 5 minus 5. So 35 minus 20. 15. We just say for O only. So that is b. V only. V only is the total number of v 30 minus all of the intersections that including v. So you have 7, 5, 5. 7 minus 5 minus 5 minus 17. 30. So here, b only is 16, v only is 13. Now, I'll look for every player that plays at least one spot. So, for at least one spot, which is f plus b plus v. This is the actual formula that I want to use. This is the actual formula that I want to use. So if they're using this day, I want to use this formula. But if you already have the f only, the b only, this thing, you already have everything like this, just sum all of them one by one. You just do 18 plus this plus this plus this plus this plus this. So when you sum all of it, what are you going to have? When you do 18 plus 10 plus 15 plus 5 plus 5 plus 7 plus 18, that is going to be equal to 73. Now, for neither, you have here in C. The sample space in this case is 80. So for neither, you have 80 minus this 73. This will give you 7. Why is it like that? Because the 80 people in total. The 73 is the number of people that play and this sport. That is the number of people that are playing anything, whether it's playing 2 sports or 3 sports or 1 sport. The number of people that are playing soccer. But now we are looking for the people that are not playing nothing. So to know the people that are playing nothing, you first find the total number of people. So how many people are there? 80 people are there. And then from the 80, you remove all the people that are playing sports. So that you'll be left with people that are not playing any sport. So all of the people that are playing sport, you add all of these people here. They're all playing sport, that's why they're easily set. So when you add all of these people here, you subtract, you do 80 minus those people, you'll be left with the people that are not playing no sport. And that number is giving you 7. So you know that there are 7 people that are not doing this sport. Alright, so that is all for the Venn diagram. What is the question? Number of students that play only football. 18, that is the A part. The B part says number of students that play just one sport. What are you going to do? 18 plus 15 plus 13. And what is that going to give you? 46. So 46 students play just one sport. Then the C part says the number of students that play at least 2 spots. So at least 2 spots. No. Yes. The number of students that play at least 2 spots. It is not the number of students that play just 2 spots. When they say at least, when they say at least 2, it means 2 and 3 also. 3 is possible. So this. You added all of the intersections. You have 3 plus 7 plus 5 plus 5 because an intersection means you're playing more than one spot. So you add them up. So you're going to have 7 plus 10 plus 5 plus 5, which is equal to 27 students. And a D part says how many students do no spot? It is 7. So yes, apparently that is the last example. On that, so that was the last example of that 3-set Venn diagram. So from now, you should be able to solve any problem that I'm giving you on that 3-set Venn diagram for this level, for this 2 level. So now I'm moving to the last one, the last part. Word problems. We're going to solve some problems in everything that we have done so far till now.